All right, let's get right into it. When you hear the word architecture, you probably think of buildings, right? Skyscrapers, bridges, the stuff that makes up our cities. But what if the next great architect wasn't a person at all? What if it was an intelligence that could design literally everything, from the microscopic code that makes us who we are, all the way up to the massive, complex systems of our cities? Well, that's exactly what we're talking about today. We're looking at AI's new blueprint for our future.
I mean, just listen to that. A city with no traffic jams, no wasted energy? That sounds pretty amazing, doesn't it? This quote, it really nails one half of the story we're telling. It paints this picture of a world perfectly orchestrated by AI for ultimate efficiency. It's an incredible idea, for sure, but it's still only part of the blueprint.
See, because before an AI can even begin to design the world around us, it first has to learn to read the most complex, most intricate instruction manual ever written, our own DNA. And believe me, that's where this whole story gets really interesting.
So, for decades now, we've known that our DNA holds the secrets to, well, everything about us. But here's the catch. A huge chunk of it, like the vast majority, has been a total mystery, kind of like biological dark matter, until now. You know, for the longest time, science was totally focused on just the 2% of our DNA that actually makes proteins. We literally called the other 98% junk DNA. Can you believe that? Turns out it's not junk at all. Not even close. It's the operating system. It's this incredibly complex switchboard that tells our genes when to turn on, when to shut off, basically how to build a human being. And figuring this part out, that's the key to understanding all kinds of diseases. And this is the breakthrough. Google DeepMind, yep, the same people who gave us AlphaFold and completely changed our understanding of proteins, they've built an AI that can finally read this unbelievably complex genetic instruction manual.
The sheer scale of what's happening here is it's mind-boggling. To really get what the genome is saying, you can't just look at one little piece at a time. You need to see the whole context, the whole chapter. And that's what this number means. AlphaGenome can process 1 million DNA letters at once. That lets it see these super complex, long-distance relationships that are secretly running our biology.
And that kind of power unlocks something incredible. This isn't just about reading the code anymore. It's about understanding it. AlphaGenome can actually predict which genetic switches are going to be flipped, how that might lead to a disease, and even how two genes that are miles apart on a DNA strand can work together. It's what's called a unified model, which means it's learning the fundamental rules of DNA from the ground up, and because of that, it's blowing every previous model out of the water. So this brings us right back to where we started. If an AI can master a system as messy and complicated as our own genome, what's the next logical step? Well, you take that same kind of intelligence, that same predictive power, and you point it at another ridiculously complex system, a modern city. And this is where we get into the idea of the autonomous city. Now, this is way beyond a smart city with a few sensors here and there. We're talking about a city that basically acts like a single living organism, constantly learning, adapting, and optimizing everything in real time.
The big, fundamental change here is moving from being reactive to being predictive. Think about it. Our cities today are constantly reacting. A traffic jam happens, then we try to deal with it. A pipe breaks, then we send a crew to fix it. An autonomous city is totally different. It sees the patterns that lead to a traffic jam and starts rerouting cars before it even happens. It analyzes data to predict when that pipe will fail and schedules maintenance proactively. It's a total game changer.
And here's where this really becomes a matter of life and death. Just look at this scenario. An accident happens. Instantly, the city's AI doesn't just clear the one intersection. It orchestrates a perfect green light corridor for the ambulance, starting from miles away. Every single traffic light is timed perfectly. We're not talking about saving a few minutes on your commute. We're talking about saving actual lives.
Okay, so we've got these two huge AI advancements, right? One is decoding our inner world, our biology. The other is redesigning our outer world, our cities. They seem like they're 1 million miles apart, but if you look a little closer, you start to see they're built on the exact same foundational idea.
And right here, this is where it all clicks together. Both of these systems, human genomics and urban systems, are trying to manage environments with millions of moving parts. AlphaGenome learns the deep rules of DNA to predict things like disease. The city AI learns the deep rules of urban flow to predict things like gridlock. It's two different problems, but it's the same core approach, using predictive AI to tame massive complexity. But of course, with this kind of power comes some massive challenges.
And what's wild is that the challenges are almost identical whether you're talking about DNA or downtowns. You've got to protect all that data. You have to make sure the algorithms aren't biased. You need to build brand new infrastructure, and you have to keep it all secure from cyber attacks. And then there's the biggest question of all. Where do we, the humans, fit in? When a system is making 1 million decisions a second, who gets to step in and say, hang on, let's do it this way instead?
And that really brings us to the final and, honestly, the most important point. This technology, it's an incredible tool. It's like an architect with powers we could never have dreamed of. But a tool doesn't have values. A tool doesn't have a vision for what makes a good society.
This quote just says it all, doesn't it? The point isn't just to build a more efficient city, it's to build a more equitable one. The goal isn't just to understand disease, it's to create better health for everyone. The AI can optimize a system like nobody's business, but we're the ones who have to tell it what we're optimizing for.
So in the end, we're left with this one big question. The AI can read the blueprints of our very being, and it can design the cities we live in with superhuman skill, but it can't tell us what kind of world we should build. That job, that responsibility of drawing the final human-centered plan, that's always going to be on us.